Dear students, I am Dr. D. Sam Garrison, Professor, Department of EEE, Rohini College of Engineering and Technology, Kanyakumari. Now I am going to explain about magnetic circuit. Actually, a magnetic circuit is made up of one or more closed loop path containing a magnetic flux. So the flux is usually generated by a permanent magnet or electromagnet and confined to the path by magnetic cores. In the magnetic circuit, the magnetic flux or magnetic line of force starts from a point and ends at the same point after completing its path. Flux is generated by the magnet. It can be permanent magnet or electromagnet. Next, MMF, magnetomotive force, is also known as magnetic potential, is a property of certain substances or phenomena that gives rise to magnetic field. MMF is analog to electromotive force or voltage in electricity. The standard unit of MMF is the ampere turn. MMF is proportional to the product of the number of turns around the core and the current through the turns of the wire. That is, F is equal to N into I. Then magnetic reluctance. It is the property of material which opposes the creation of magnetic flux in it. It's analog to resistance in an electrical circuit. The reluctance of the material is given by R is equal to L divided by mu A, ampere turn per Weber. Magnetic permeability. It describes the nature of the material, that is, it is a material property. It is easy with which the material allows magnetic lines of force to pass through it, or the degree to which magnetic field can penetrate in a given medium. Mathematically, it is equal to the ratio of magnetic induction B inside the material to the applied magnetic field intensity H. Unit is H per meter. That is, mu is equal to B divided by H. Relative permeability, it is defined as the ratio of flux density produced in a material to the flux density produced in a vacuum of the same magnetic field strength. Thus, mu r is equal to mu divided by mu 0. Already mu is equal to, you know that product of mu r and mu 0, that is B divided by H, where B is equal to mu 0 mu r into H. Then magnetic equivalent circuit. Iron core without air gap. Sorry, in this circuit there is no air gap. Analogy between the magnetic circuits and the electric circuits. Then iron core with air gap. So here some small air gap is there. This air gap will have some reluctance that will be in series with the reluctance of the iron core. Fringing of the flux lines occurs when the air gap length is somewhat large. Actually, more flux is concentrated in the inner portion of the core than in the outer portion. Fringing effect. The effective cross section of the area of air gap increases, so the reluctance of the air gap decreases. The flux density Bg is less than Bc. Bc is the flux density in the core. If the air gap is small, the fringing effect can be neglected. That is, Ag is equal to Ac. Bg is equal to Bc is equal to pi divided by Ac. In practical, large air gap will be divided into several small air gap to reduce the fringing effect.